Testing. We're going to be working some linear equations, and this subject here is intermediate algebra. Okay, so what is a linear equation? Well, I guess the best thing to do really is kind of give some examples first. If I had this equation, 5x is equal to 100. This is a linear equation, and the idea here is we want to solve for x in this problem. That is, find the solution that so when we plug it in for x, we get a true statement. And what we're going to do here is I'm going to multiply both sides by 1/5. 1/5 times 5 is 1, and 1 times x is just x. And so we're left with x is equal to, now 1/5 of 100 will be 20. So 20 is our solution. Now you notice we get another equation here. We started out with an equation and we end with an equation. But actually what we're looking for is what number can I plug in for x so that this makes us a true statement. So 5 times 20 is equal to 100. Let's look at some others. Okay, what about negative 3x is equal to 0. So we want to solve for x in this problem, and what we're going to do is I'm going to multiply both sides by negative 1/3. So negative 1/3 times negative 3 is 1. And a number times 0 is just 0. So as you can see, if I plug 0 back in up here, we end up getting a true statement. 0 is equal to 0. Alright, let's look at this one. 8x is equal to negative 144. So once again, I need to get a 1 in front of the x here, and I'm going to do that by multiplying by 1/8 to both sides. And of course it doesn't matter whether I put the 1/8 on the left side of negative 144 over here on the right hand side. So 1/8 or an eighth times 8 is 1, and so we're left with x is equal to, we have a negative number times a positive number, and this ends up becoming a negative number, and that is negative 18. Alright. We have a negative 0.4 times x is equal to 14. So this time I'm going to multiply by a negative 1 over, this is its reciprocal, times negative 0, just rewriting. X is equal to 14 times negative 1 over 0.4. And of course, multiplying these two guys here together gives me x is equal to, and this here should end up becoming negative 35. So I just use the calculator and plug that in here. In this particular problem here, I'm going to go ahead and state the equation, and I'm going to give you the answer. It's going to be up to you to try to show that x is equal to 36. So work on that. Real quick hint, remember whatever you multiply 2/3 by, you want to make sure that you get a 1 here, right? A 1 times x. Okay. Hey, we're in intermediate algebra and we are looking at linear equations. Okay, so let me write out a linear equation here. We have negative 7 halves. In the last one, I just stated the equation and asked you to actually find the solution. So I hope you was able to do that. I think I actually gave you the solution and seeing if you can show how to get there. Okay, so this is similar to the last problem that we just did. What I'm going to do here is I'm going to go ahead and multiply both sides by negative 2/7. And I'm going to put parentheses around this because we're dealing with this negative sign. Negative 7 halves. X is equal to negative 2/7 times negative 49. So we've got all these negatives we're dealing with here. So a negative number times a negative number is a positive number. All right. And we have 2/7 times 7 halves, that's its reciprocal. And what's going to happen here is the 2's are going to cancel out and the 7's are going to cancel out, and we're going to be left with just a 1. So once again, we have 1 times x, but we don't write that, we just write x. Now, we have a negative times a negative, so that's going to become positive. We can say that 7 goes into 49 7 times, so let me not skip too many steps here. So we're going to be left with 2 times 7. This 2 here, and then 7 goes into 49 7 times, and 2 times 7 is 14. So now we actually have a new equation here, but our solution is 14, and if we were to plug 14 in right here, this left-hand side should equal negative 49. Oh, let's look at another one here. So we got negative 7 times x minus 2 is equal to 12. So the first thing I'm going to do, we have a negative 2 here, a minus 2. I'm going to add 2 to both sides to get rid of this. So negative 7x minus 2 plus 2 is equal to 12 plus 2. And then we want to simplify this down. We have negative 7x is equal to 14. Now I'm going to multiply both sides by the reciprocal of negative 7, which is going to be negative 1 over 7. Negative 1 over 7. And that's going to leave us with x is equal to, now we have a positive number times a negative number, so that's going to be negative. And 7 goes into 14 2 times. So x is equal to negative 2. So our solution is negative 2, and if we were to plug it in up here in this equation, this side better be equal to 12. And I'm sure that it is. We have 0.2 x minus 1.31 is equal to 2.39. Whoops. What I'm going to do here is I'm going to go ahead and give you the solution, which is you should come up with 18.50. And I want you to try to show that x is equal to 18.50 once you manipulate this guy around. We are in intermediate algebra and we are working linear equations and finding solutions and having a good time. Well, hopefully anyway, we're having a good time. So let me write out an equation here. So as you can see, these problems should be getting more difficult as we go along. So we have negative 5x plus 7 is equal to 10x plus 11. What I want to do is I'm going to get the x's over to one side and all our constants over to the other side of the equal sign. And by doing that, I'm going to take, because I have a positive 10 as my coefficient in front of this x, and then I have a negative 5, what I'm going to end up doing here is I'm going to end up taking this negative 5 over here to the right hand side, and then I'm going to take this 11 over to the left hand side. And of course, by doing that, I'm going to add 5x to both sides. Okay, so now we have negative 5x, or we have a positive 5x minus 5x, so that's going to make that go away. So I'm left with 7 is equal to, I'm going to collect my like terms here, so that becomes a 15x, and then we have the plus 11. So now what I'm going to do is I'm going to subtract 11 from both sides. I've got to get this 11 over here to this side. So 7 minus 11 is equal to 15x. We have a plus 11, and then I'm going to subtract 11. So now I'm going to be left with, we have a 7 minus 11, so that becomes a negative 4, be their difference. And because we have a positive 11 and a minus 11, that goes away. That's what the whole idea of that was. And now what I'm going to do is I'm going to multiply both sides by the reciprocal of this 15. So 1 over 15 to both sides. And I always put a parentheses around my negative here. So now we're going to be left with x is negative 4 over 15. So we've manipulated this equation around down to its simplest form to this final equation here, but the solution is negative 4 over 15. If we were to plug this in up here, in for x, which is something that you should probably do, you would see that the left-hand side will be equal to the right-hand side. So by saving some time, I've written this out already. So we want to solve for x in this problem, and what I'm going to do here is I'm going to get rid of this fractions. Okay, I'm going to get rid of this 5 and this 2 down here in the bottom, and I'm going to do that by multiplying through by 5. Okay, to every term in this equation. And so 5 times 1/5 is just 1, so we'd be left with x minus 5 times 4 is 20. 5 times 3 is 15, and 5 times a half just becomes 5 over 2 x. Now I'm going to multiply through by 2 to every term in this equation to get rid of this 2 down here in the bottom. So this becomes 2x minus 40 is equal to 2 times 15 is 30. Alright, in this section here we're going to be talking about equations. So an equation is a statement where two algebraic expressions are equal. Here's an example. So let's say, for example, we've got 3x and we're going to set it equal to 2x plus 1. So this is an equation. We have, this is an expression, 3x is an expression, and 2x plus 1 is an expression, and we set both of our expressions equal to each other and we get an equation. And the idea here is we want to find all the values of x in which the statement is true. In other words, what can we plug in for x on this side over here, and we plug in the same number over on the right hand side, and then both sides are going to be equal. Like for example, we got 6 would be equal to 6. So we could possibly have one solution. We're going to look at all our possibilities here. You could have one solution, or you might have many solutions. Okay, so we could have many solutions. There may possibly be an infinite number of solutions also. So an equation that is true for every real number in the domain of the variable, it is known as an identity. Here's an example. If I had 2x plus 2 is equal to Okay, in this particular case here, this is going to be true for every real number in the domain. That is all the numbers that we can plug in for x here. So every real number that we plug in for x, both sides are going to be equal to each other. This is known as an identity. However, this equation up here is known as a conditional equation. We might have one solution, or some solutions, or maybe no solutions at all. So this is known up here as a conditional equation, and this is what we're going to mostly be working examples on, focus on, is conditional equations. Okay, there's a specific type of equation that we're going to work some examples on, and these are what are called linear equations. And if I was to write y is equal to 3x plus 5, or maybe just y is equal to 0, is that a linear equation? Maybe you can answer that later. But so this is a linear equation. The actual standard form of a linear equation, so we'll look at the standard form. The standard form is ax plus b is equal to 0, where a is not equal to 0. Okay, so this is the standard form of a linear equation. And this has exactly one solution, and we can prove that just by solving for x in this problem. So if I wanted to solve for x, I would take this b over to the right hand side, and that gives us negative b, and then I would multiply both sides by 1 over a. Here's the reason why a cannot be equal to 0, for example, and that is because you can't divide by a here. Right? Negative b over a, you can't divide by a. So let's look at some examples. Hey, we're going to work some examples of how to find the solutions to linear equations. So let's just get started here. So let's say that, for example, we have 2x plus 1 is equal to 5, and we want to find all the solutions that make this a true statement. So what I'm going to do here is I'm going to take this 1 and I'm going to subtract, I'm going to get rid of the 1 here, and I'm going to subtract 1 from both sides. So we have 2x plus 1 minus 1 is equal to 5 minus 1. And 1 minus 1 is 0, so we're left with 2x is equal to 5 minus 1 is 4. Now we want to get rid of this coefficient here, so I'm going to multiply it by a half. And a half times 2 is 1. And so we're left with x is equal to, and then we have 4 times a half is just 2. Right? So our solution is x is equal to 2. So we started with an equation and we basically ended with another equation. But it turns out that this is also a solution, x is equal to 2. When we plug 2 into this up here, and we'll go ahead and do that just to demonstrate that both sides are equal. And so 2 times 2 is 4, and 4 plus 1 is 5. Alright, let's work another example. Okay, let's see here. How about if we had 7 minus 2x is equal to 10. Alright, so we want to solve for x here. I want to find the solution that makes this a true statement, and that is what we're going to do here. I'm going to go ahead and we got a couple different ways of doing this. Because I'll have a negative here, or there's a minus sign, I'm going to go ahead and take this guy over to this side. And so by doing that, I'm going to go plus 2x. 10 plus 2x. So as you can see, we have a minus 2x and a plus 2x, so that's going to be 0, right? So we got 7 is equal to 10 plus 2x. Now what I'm going to go ahead and do is I'm going to subtract 10 from both sides because we need to get this 10 away. You know, it's kind of like what's going on here. It seems like we hadn't really gone anywhere, but it's because of this minus sign. I'm going to go ahead and subtract 10 from both sides. So I'm going to kind of assume that you haven't done this before. And a minus 10. So as you can see now we have a minus 10 and a plus 10, so that's 0. And so we're left with 2x. We have a negative 10 plus 7, and that's going to give us a negative 3. Now what we want to do is want to multiply both sides by a half. I'm going to put a parentheses around that right there because of this negative. And so half times 2 is just 1, and 1 times x is just x. And so then we end up with negative 3 over 2. So that's going to be our solution. And if we were to plug in negative 3 halves into this up here, we should get 10 on this side. And I'm just going to kind of inspect this real quick. Plugging negative 3 halves in right here, the 2's cancel out, so you have negative plus 3, that would be a positive 3, and 7 is 10. Okay. We're going to go on and work lots more examples. Okay, let's look at this linear equation here. This time our unknown is going to be defined as t. Okay, so t is the our unknown variable that we're going to be solving for. So we don't have to use x every time. We can use anything we want. Alright, so what I'm going to do here is I'm going to go ahead and distribute this 2 across, and then I'm going to distribute the 3 across, and then we're going to collect like terms. So 2 times 13 is 26 t. Minus, and 2 times 15 is 30. plus 3 times t is 3t minus, and 3 times 19 is going to be 57. So now what we want to do is collect all our like terms up. So we have 26t and 3t, so those are two our like terms, and that's going to give us 29t. And then we have this minus 30 here and minus 57, so we're going to end up getting a negative, and that should be 87 if all is correct. Now what we want to do is go ahead and add 87 to both sides so we can get rid of this minus 87. So I have a minus 87. We're going to add 87 to both sides. So I'm not going to rewrite that 0. And then we have 29t. So that's going to give us, that's going to cancel out to be 0. And then we have 29t is equal to 87. And then we're going to multiply both sides by 1 over 29. Over 29, and so we end up with t being equal to 87 over 29, and of course we can reduce all of this down, and I do believe that 29 goes into 87 3 times. So t is equal to 3. So what I want to do here is I'm going to go ahead and show that this is true by taking this 3 and plugging it back in up here into our equation. Okay, so in the process I did some erasing here and I ended up, okay, erasing part of the problem. Alright, so what we want to do here is I want to take this 3 and plug it in for t. So 2 times 13 times 3 minus 15 plus 3 times 3 minus 19. And this is so we can check our work and make sure we did everything correct. So what you want to do here is you just want to go through and do the arithmetic. 13 times 3 minus 15, get that number, multiply it by 2, and so forth. And I'm almost positive that this is going to all equal 0 over here on this side. Because this is a 0 over on the right hand side, and that means that this side here is going to have to equal to 0. So I'll let you test that out. Okay, we're looking at linear equations and how to solve for them. So the best way to do that is just for me to work a bunch of examples. Okay, so what we've got here is we've got some brackets over here, and the reason I do that is sometimes too many parentheses gets confusing, and so I may throw in some brackets, but just pretend this is like a this is an open parentheses and a closed parentheses. So let's see if this equation has a solution. So what I'm going to do here is I'm going to go ahead and distribute this 6 across first, and so we end up with 6x minus, and we're going to have a 6 here, so we have 2x plus 3. And now that I've distributed the 6 across, we can drop these brackets. Except we want to go ahead and close this in here. So we have 8 minus 5x. Now what I'm going to do is go ahead and distribute the 6 across. So rewriting this 6x minus, so 6 times 2x is 12x. Now because we have a minus out here, I'm going to go ahead and distribute this because pretend this is like a negative 6. So this is like a negative 6 times 2x is minus 12x, and then just go ahead and distribute it across, and so we have a minus here, and 6 times 3 is 18. Alright, now what we want to do is collect our like terms up. So we have a 6x minus 12x, and 6 minus 12, well, that would be a negative 6. So, and that's really all the like terms we have on the left hand side. Okay, now what I'm going to do is I'm going to go ahead, and because we have a minus 6 here and a minus 5 here, this is smaller than the minus 5, and I'm going to go ahead and take this over to the right hand side, and I'm going to take this 8 over to the left, and I'm going to do this all at one time here. So in other words, what we're going to be doing here is we're going to be adding a 6x to both sides, and of course if I have a positive 8 here, I need to subtract 8. So hopefully you can hang in there, keep up with me. So I have a 6x and a minus 6x, so that's going to go away, right? So that's 0. And then we have a minus 8 and a minus 18. I'll just rewrite that. And what's going on over here? Well, we had this positive 8 and a minus 8, and so that's going to go away. And we have a negative 5x plus 6x. Now I'm going to go ahead and simplify this down while I'm here. So this just becomes, pretend this is like a 6 minus 5, which is 1, right? So this just becomes x here. Negative 5x plus 6x is just 1x. And now we can just go ahead and finish this up. We have a negative 18 minus 18, and that'll give us a negative 26. Now remember that the way to check this, right, you want to take this negative 26 and plug it into where x is located, right? Plug in the minus 26, and then we should get the left hand side should be equal to the right hand side. We want to make sure we plug in that minus 26 over here and then do the arithmetic. Okay, so let's try to find the solutions to this equation here, if it has any. So what I'm going to do first is I'm going to distribute this 8 across. So we have 8x, 8 times 2 is 16. Then I'm going to distribute this minus 3 across. So we have minus 6x, right? 3 times 2 is 6, and then minus 3 times 1 is just minus 3. And I'm going to go ahead and distribute this across over here also. Okay, now what I want to do is collect my like terms up. 8x and minus 6x are like terms, and so 8 minus 6 is 2, so I'm left with 2x, and then 16 minus 3 is negative 13, or I'm sorry, positive 13, whoops, is equal to 2x plus 10. Now take notice that we have a 2x over on the left hand side and a 2x on the right hand side, and what's going to end up happening is if I were to subtract 2x out on both sides, we'd end up with 13 is equal to 10, and we know that's false. So this guy here has absolutely no solution, so no solution. Alright, let's look at another one. We have a half x plus a half equals x. So what I'm going to do is I'm going to multiply it by 2 all the way across. So multiplying this side by 2 and this side over here also by 2. So 2 times a half is 1. So we're left with x plus, and 2 times a half is 1. and then we just have 2x. So now what I'm going to do is I'm going to subtract 1 from both sides, and I would normally write this out over here to the right of that, but I just put it under there. So a positive 1 and a minus 1 is 0, so we're just left with x is equal to 2x minus 1. I probably should have done this a different way. Wasn't paying attention, but that's okay. It's all going to work out in the end. I'm going to go ahead and take this 2x over here to this side, and that means that I'm going to subtract 2x from both sides. Yeah, there's always more than one way to work a problem out. But negative 2x, positive 2x is negative x, and then we're just left with a negative 1. Now what I want to do here is to get rid of this minus sign, or this negative sign, I'm going to multiply both sides by negative 1. And as you can see here, I end up with x is equal to 1. So that's going to be our solution. X is 1. Alright, let's look at this one here. Hopefully I've got enough time. Minus x over 2 is equal to 3. So I'm going to get rid of this fraction. I'm going to multiply both sides by 5. And so we end up with x minus 5 halves x is equal to 15. And then I'm going to multiply both sides by 2 all the way across. So we end up with, and I'm going to skip a step here, hopefully you can keep up. 2 times 15 is 30. So now we have 2x minus 5x, that's a negative 3x, equals 30. And then I'm going to multiply both sides by negative 1/3 to both sides. Alright, and so we end up with x is equal to negative 10, and we can plug that back up into our original and actually test that out, and that should work out.